Oh. Turn it on. Hello? What is going on here? Come on, come on. Come on. Oh, here we go. Oh, what the heck, Ben? Let's see. Oh. Okay, here we go, here we go, here we go. Here we go. There we go. Right. Let's get started. Electromagnetic waves. Okay. A little bit to look at today. Right, so, first thing, Ben, light is a very special type of wave. It's an example of an electromagnetic wave. Here are more examples, okay? So, other electromagnetic waves are radio waves, Wi-Fi, mobile phone, X-ray, infrared. These are all examples of electromagnetic waves. Have you seen these before?
Like 4G, 5G.
Yeah, these are all electromagnetic waves. Yeah. And what's amazing is that all of these waves are actually the same thing. They're all the same.
Oh.
The only difference is the frequency. So a radio wave and a Wi-Fi and an X-ray and a 4G and a 5G, they're all the same. Their only difference is their frequency. So if I could take the light and change its frequency, then I can turn it into Wi-Fi. Yeah. Which I think is interesting. It's amazing.
Yeah.
Amazing. Same for radio. So I think what you should write from this page, well, no, you don't need to, because on this page, I'm going to ask you to draw this. Now, this is called the electromagnetic spectrum. So you can see when the wavelength is big, that means the frequency is small, you have radio. And then if you make the frequency higher, you get microwave. And if you make the frequency higher, you get infrared. In the middle here is the light we can see, visible light. Then we have ultraviolet, UV. Then we have X-ray, and then we have gamma. So this is called the electromagnetic spectrum. Do you know where Wi-Fi is? Where would Wi-Fi be? Do you know which?
What is infrared?
Infrared? No, it's not actually.
Oh, I mean, what is this?
Oh, what is this?
I know this.
You know, this signal here is infrared
Oh.
from the remote also. And the picture also the heat. Yeah. But do you know where Wi-Fi is?
Radio?
No, it's here actually.
Microwave.
Yeah, it's the same as microwave, same frequency.
Okay.
It's interesting. Mobile phone, I think, is here to the left, between these. I think. Wi-Fi, mobile phone. Yeah.
Okay.
Yeah. This is in the hospital. Now, do you notice, Ben, that these ones are bad for your health?
Yeah.
Yeah? These ones are not bad for your health.
Yeah.
So, you can split this down the middle. These will harm you, and these will not harm you.
Okay.
Some people say mobile phone or Wi-Fi is bad for your health.
Yeah.
This is completely wrong. 100% wrong. Anything to the left here, not harmful. Here, harmful. So, what you need to know for the exam is in the exam they sometimes ask you to list this in order. They would say, list the electromagnetic spectrum. So they want you to write down radio, microwave, infrared, visible, ultraviolet, X-ray, gamma. You need to know them in order. So you also need to know that these ones are long wavelength, low frequency, low energy, and these ones are short wavelength, high energy, high frequency. So if you can try and add this to your notebook, you don't have to draw it, you can write at least. Beautiful. Ah, wonderful.
And
Yeah? Okay. Continue? Yeah? Okay. Now, the piece we want to have a look at is the piece in the middle, which is visible light. Because visible light, there's lots of different colours of visible light, obviously. And the reason that there are different colours is because there are different wavelengths. So, for example, the red colour, it has a big wavelength, and the purple colour has a small wavelength. Now, also, I'm sorry to tell you this, but they also need you to know these colours for the exam. So, for example, here at purple is 400 nanometers, and here at whatever that is, turquoise, 500 nanometers. And here at yellow and orange, 600 nanometers, and here at the red is 700 nanometers. They need you to know these numbers.
is between two colors.
Yeah, so like for example, this is green, so that's 550. This is blue, that's 450. This is orange, that's 650. Yeah. Red, do you know all your colours? Red, what's this?
Orange,
Yeah.
yellow, green, blue, purple.
Purple.
How to say the word? It's two word and
Yeah.
purple.
Yeah. Indigo and violet.
Okay.
So we start at, like up here, be about 800. So, if you can copy this please, that would be great. I can write it down for you, Ben, actually, that might be easier. 700, this is the wavelength, 700 nanometers, 650, 600, 550, 500, 1, 2, 3, 4, 5, 6, 7. Would that get us all? So 700 is definitely red, and 650 orange, and 600 yellow, and 550 green, and 500 is a blue, and then indigo and violet. I'm not sure how to spell violet. These two are purple. Yeah? Yep. Okay. Now, in the exam, they sometimes like to ask you for 3 properties of electromagnetic waves. So the first one is electromagnetic waves are transverse. So that means, you know, they look like this. That's the first thing. Okay. Second thing is that electromagnetic waves travel with a constant velocity in a vacuum. So in other words, number 2, their speed is equal to c, which is roughly equal to 3 times 10 to the 8 meters per second in a vacuum, in empty space. Okay? And this is all these waves are all c. Yeah. Okay, and the last one, the most amazing one, is that electromagnetic waves need no medium of propagation. No medium of propagation. Now what does that mean? That means they can move in a vacuum. Now think about it, that's amazing, okay? For example, if I have water, then the wave can move in the water, okay? If I have air, then the wave can move in the air. Okay, fine. But these waves, they don't need anything to move. They can just move in a vacuum, which is strange because then it makes you wonder what is moving up and down, you know, because there's nothing there. So I think I only have 3, do I? Yeah. These 3 are good for the exam.
No medium of properties.
Mm-hmm. Yeah. Is it okay?
You mean is this?
No, I mean, you don't need any material. It can move in empty space.
Okay.
Yeah. Do you know what I mean? Like for example,
So it's just
yeah, in empty space, it's just moving by itself. Doesn't need a material.
okay.
Like for example, an ocean wave needs water. A sound wave needs air. A music, you need a string.
Oh, they can
Yeah.
we can.
No material necessary.
Okay.
Yeah. Right. Because V always equals C, then we can say V equals C equals lambda F. So if F is known, then lambda is known, and vice versa. So, you know from last day we said V equals lambda F. So C equals lambda F. So, lambda equals C over F, or F equals C over lambda. If you know the F, you know the lambda. You know the lambda, you know the F. And they're opposites. So if lambda is big, F is small. They have opposite relationship. Okay? Right. Now here's a new word for you. The polarization of light, or any transverse wave, is when the vibrations are confined to a single plane. And here's a picture showing that. So I'll show you with my hand, okay? What happens is the light is moving in many different directions, and when it comes to this screen, only the light that's moving this way can pass through. So it means what you've done is you've taken all the light moving many different ways and you forced it to only move this direction. And this process is called polarization. When you take all the light waves and only accept one slice. Yeah? No?
No.
You can't see that it's not clear?
Is this light moving
Yeah.
to the right?
Light's moving to the right. So what happens? You have some light coming in this way, some coming in this way, some coming in this way. But only the light that's going up and down can pass through, because this one here, if it's moving this way, it's blocked. Only the
parts.
blocked parts of it, yeah. This is how the sunglasses work. You know sunglasses? What happens is the light comes in and most of it's blocked and only some of it comes in. So that's how I don't know if you've ever heard of this, but you have these things called polarized sunglasses. Have you ever heard of that? They're the expensive sunglasses, you know, like 50 euros. You know these sunglasses?
No.
Okay, well I don't have them. But they're the good sunglasses that they use this to block the light. So they're called polarized sunglasses. Yeah. You need to write this, and you need to try to draw this. Yeah. Try it.
The definition.
Of course you need the definition too, yeah. Yeah, draw. Yeah.
You write. You print the picture.
Print the picture.
Yeah.
Ah, you can draw it. Watch. Watch.
Yeah, like this.
Easy to draw. Draw this. And then you have some light going. Blocked. And then the one's going because this one is vibrating up and down. This one is vibrating side to side. So this one passes.
Okay.
Yeah? Easy peasy. Okay. Right, here's a small question for you to try, Ben. What is, yeah?
The block,
Hmm?
the block light is polarization.
No, we say the light that passes through is
pass.
polarized.
Okay.
Yeah.
Okay.
Good, okay. Here's a small calculation question for you, Ben. What is the frequency of red light? And the wavelength is 700 nanometers. I want you to calculate F. Do you remember the V? The V is C.
I know. No, but is F.
Yeah.
And is sorry.
3 times 10 to the 8th.
I mean the.
Oh, nano.
Nano is.
Minus 9.
Oh.
No, 700. Yeah. So minus 6. Minus 7. 7.
So it's 13. Oh no. It's 10.
Yes. Yeah?
Just 4 times 14.
Yeah. Good. Okay. That's all for this lesson. It's an easy lesson to get started. So, let's see. What we'll do before we start the next lesson, I'll let you try these for a few minutes. They're very easy. I think it'll only take you like 5 minutes.
Giga is G.
Yep.
Big G.
Yeah, G.
But why is so big?
That's what it is. That's what a Wi-Fi router is. 2.4 gigahertz.
Oh, it's F. Okay.
Yeah.